pourrais juste vérifier que ça stream sur... ça a l'air. Ah. Donc, il n'y a personne. Mais c'est pas grave. Sur...
Ouais, c'est bon, ça marche sur YouTube.
Christophe, ça. Hello everyone. This is the third session of the Paris Mathematical Model of Consciousness Seminar and the second session for our series on integrated information theories, number 2. And today we have Grégoire Sergeant-Perthuis from the University Sorbonne in Paris, will be entering into some further mathematics, and Gaspard Fougea from the École Normale Supérieure Paris-Saclay will further elaborate on the theory. For those who may join the Zoom session, you can ask questions if you wish, but please raise your hand so that we can give you time to speak. And of course, for those who would be attending on the YouTube live streaming, we'll try to monitor if there's anything on the chat going on, but we cannot count it. So better for you to join the Zoom session. So without further ado, here is Grégoire. I'll let you set up the mic.
Okay, so hello everybody. So going back on IIT this time was like it's the follow-up of the first session of the seminar PMMC. So which is now called PMMC2 because we included cognition in not in the title, not just consciousness. But so we will try to still stay focused on models of consciousness for some time on some sessions, but then maybe broaden up also for models of cognition also. So last time what we did with the IIT2 is we presented the general framework and went into Big Phi. And what we said is that what I said is that I was unsure of the expression of Big Phi. So I make a little mistake in the expression of Big Phi, but it's not that catastrophic. Because I realized that it was okay. So what I had presented was, I think kind of okay. So we will just sum up a bit of what we saw on the last session and then put the expression of Big Phi once again, but with the little typo that is away this time. And then I will leave Gaspard present the link between the axioms and the equations. So once again, the papers that I use are the one from so the mathematical structure of IIT, and the second one is IIT 4.0. Okay, so the presentation of Big Phi will be based on this article. And Gaspard will talk a bit more about 4.0. So this article, they basically cite 3.0. But I think that the general formula stay the same, maybe in the details, in the choice of the distance, for the ones that we call the distance between, let's say, the distribution and the product distribution when you split together the variables. This can change, but I think the global definitions stay the same. So what we had to define IIT, we needed first a collection of variables. So let's say I, so we call I a collection of variables. And for each variable I, you associate a space of states. So the configuration of the system is omega, which is the product of the xi for I and the I. And then you have a second point, which is that you needed a dynamical system, so we denote T, that goes from omega to omega. And in fact, it's a probabilistic map. So most of the time, so depending on the conventions, you can note it like this, or you can also note it as a function, which is, as you see, there is some send any configuration of omega to a probability distribution on omega. So this is an example with omega is finite. P is a stochastic matrix. That you will note that T omega 1, omega 2 for the bubble omega 1, omega 2 to the quantity, and such that the sum over omega 1 for every omega 2 is equal to 0. So we saw also an important, like one of the main operations that has to be introduced is the notion of cuts on the transition, on the transition T, which corresponds to, so if here you have your collection of variable I, here you have your other collection of variable I, and T sends configuration of xi, so omega to omega. You want to be able to see the impact of T when you restrict it to a sub-collection of variables M into, and so the impact of a sub-collection of variables M into a sub-collections of variable T. So M would be the mechanism in the IIT correlation and P the probability. So there's one way to do it. If you want to define T and E, you can always define it as the conditional expectation with respect to omega n. So here n is a subset of T of I, sorry, and P is a subset of I, where you marginalize only you consider only subsets A that are inside of omega P. Okay, so what do I mean by omega P? So this is things I already introduced last time. So here. So omega P is the product of the I and the P of xi. Omega n, similarly, is the product over I and n of xi, and this defines a sigma algebra. So it can define the space of functions that only depend on the variables that are in M and not on the other one, and you can define the conditional expectation with respect to this. So we recall that last time we were able to cut, let's say to take a piece of the dynamical system and consider only the impact of a sub collection of variables to another sub collection of variables. And this was possible through the choice of a prime. So we have C that goes from omega to omega, the prior Q that is inside here omega, then for any medium such that I, the omega will be plot of the side. We can define C and P at omega T. Then, as the conditional expectation of being inside of omega T, condition to say configuration omega n. So let's keep simple. So the prior, most of the time, that is considered for IT is Q uniform. They consider a further specification on the shape of T, which is that T is for each W, for each omega fixed is a product of the distribution, means that the variables are independent, but we will consider any T because we don't need to go into these details. But what is important is that Q is chosen uniform if you want to be able to refine the formulas that are in the articles that I was discussing before. And from there, now we can define, so we can define little phi. So it's little phi is defined as the minimum divergence that you will have. So sorry, so for this is for any mechanism N, and I focus only on effects and not on causes, which I already stipulated last time. So phi of N is the max over the P of the minimum over the partitions that you can make, so over subsets of N subsets P of the distance or divergence between T and P and T P. So T A B T A bar B bar. So this, I need to recall what I mean by this, but just for people who remember what we were discussing last time, this is what we introduced. So little phi, we have an explicit expression, which is as basically how far the dynamic on the restricted subset of variables M and P is from the induced dynamics by, let's take another color, partitions of N and P. So now I decide to cut N and P in two ways, A and A bar, B and B bar. And I want to say that there's a dynamic that goes from A to B, which is T A B, and another one that goes from A bar to B bar, that is T B bar B bar. And I want to be able to compare the induced dynamics from each of the subsets of N to the dynamic that N induces on P. Now I have two dynamics that I want to glue together. I do it by taking the tensor product. And this is how you get to this expression underneath. So do you have any questions here? So back here. Okay. So now, I will just introduce a notation, which is to say that so in this optimization problem, EM, we can also define, let's say, psi. So all this depends on the state, which I wrote in the notes. So there are notes with respect to the sessions online, and it's exactly the notations I presented before in the last session. But here, so this depends on the state, which I didn't specify in this expression, just to recall what we're doing. And now I will just reintroduce the state, because the part that I will be introducing now is talking about the big phi, and it is where there's a slight modification with respect to last time. And then once again, I will say that we're not like, this is like a study group on IIT, and so what we're trying to do is trying to explicit the formula from the different articles, and so to be able to present it in a way that we understand, and we hope that can be easy, or let's say accessible to other people. So we're learning at the same time that we're presenting it. So here psi, I will define psi of M of x of a state S. So for a state S inside of N. It's simply the one that maximizes the quantity. So we're looking at the P optimal for this quantity. So in particular, say an extent is inside of is a subset of R. So it corresponds to, for one mechanism, looking for the P that is the most whole, which means that is such that you cannot, it's the most difficult to break it into two bits, into two like disjoint parts. So it's the distribution, it is the P for which the dynamic induced corresponding to P is the furthest from the dynamics induced by its parts. So now the big phi place, so the big phi is going to do it's going to do the same process here of computing phi m, but this time for any subcollection of a given n. So this is why it can be a bit difficult to and the way it's presented is because this is the building block for how much the mechanism is, let's say, let's say unbreakable, and the big phi is seeing how much the subparts are also unbreakable, the subparts of it. So so consider a partition B, which is this time inside of psi inside of S, and we will consider So we will consider for a given n, let's say for any a inside of n, we are going to consider the quantity which is divergence from T of a for a given state, let's say, to psi of a xa, and T of a xa to B tensor T of a xa So it means that we're going to consider one B that is inside of S and an A inside of the mechanism M, and we're going to see how much we can break the mechanism with respect to the partition given by dV bar. So there are two different things in this quantity from the one that we considered here. The first one is that here you can remark that B is inside of S. So B is not explicitly inside of C of A of XA. So if you choose for A the optimal P, and you want to cut the optimal P into two pieces, you should normally consider a subset of say of X of A of XA and not a subset of S. So if you start with A here inside of A, and you want to go to the optimal CA of XA, you have a transition from one to the other, TA CA of XA, and you want to see how much of this far from breaking it into two dynamics. This time, BB bar, but BB bar is not inside of psi of AXA, so what I'm saying is it's not completely correct. What I should say is that I intersected with psi of AXA. And there's at least I feel from the paper on the mathematical models of IIT, this is the last part of the appendix, there's a bit of an ambiguity with respect to how you choose the partition when you define the big phi of Xn. So the way that we're going to do it is simply to make it have some sense. We're going to say we're not going to take some B here, but we're going to take, which is natural, B intersection with the set it should be inside. And we will move this B of A. And same thing for the complementary. So we will move this as B of A. So here there should be A. And same thing for the complementary, B bar A. So B bar A is B intersected with the step where it should go by AX. I said there were two subroutines. That's the first one. The second one is that if you remark what we did before is we cut N into two pieces also, which we don't do here. Here we do not cut A into two pieces. But doesn't change anything with function you consider. You can always take the tensor product. So it's the tensor product once you fix XA, so it gives you measures on the space of on omega, and so if they find the two sets of particles, we can still do it. So this also is well explained. Can you see this, or should I write it bigger? Maybe I should write this bigger.
We can see it, but it's always better to write it bigger if you can, but it's visible.
So this is really the last part of the article, of the appendix of the article of mathematical formulation of IIT. So of the article of mathematical structure of IIT. And so once again, I see an ambiguity, maybe I'm mistaken, and I would be happy to have some comments if some people who are really specialists of IT tell me, no, there's what you're saying here is maybe not exactly this, you're wrong, or it's true there's an ambiguity, or any comment. Okay, so we consider an A inside of the big M, then a transition T from A to the optimal like the optimal P for which we cannot break the dynamic. For any A, we will consider a partition B bar of S inside of S. Do the same colors that use blue, so it should be blue, green. At B and B bar. And so we cannot say explicitly that we cut the dynamic induced by T with respect to B and B bar, because we need to say that it's inside of say omega X. So what we will do is just consider B bar A, B of A, which is simply B cap say omega X. And here B bar cap say X. Maybe that's clear. Okay. So what we will do now to define phi, big phi of n and of a state xn. This is the definition. And it's equal to the sum over all the A included of n. And sorry, depending on the partition you choose, sum over all the A included of n of phi of A. So phi is defined as the max. Right? And now the distance that we just stated before, TA XA, psi A XA, where XA is just the restriction of X when, so it's just XI for I with A. And here, see, EA. So TA A bar. So last time, the only imprecision I did is that I considered, it was my mistake, that this quantity was not with respect to a subset of A, but with respect to n, so that it was always fixed. And the partition was cutting the same set, say, n of x, and so we could take away phi of A. And this is what the formula I gave at the end of the last session, where the phi of A was outside, had the sum, and here I had n instead of having I had psi m x n instead of psi ax. Okay. And now we finished, because basically, so this is like a little phi for all the subsets of n. And so now if we want, so this is like the divergence, sorry, this is computing how far the subsets of n are from the dynamic induced by the partition given by B. So we're going to take, so recall we had n, it induced a dynamic on P, and we looked at the partition. We do the same for any subset of n, and we try to see how far the dynamic induced by the subsets of n are from the dynamics induced by the partition of B. And so of course we want to do to look at the minimum value on B, because we want to look at what is the worst case scenario where the transitions from A to the optimal purview P is in fact, so I call purview P this one. Maybe I'm mistaken when I'm saying this, but it's the one that maximizes the distance for each A. So we're trying to see the worst scenario when the sub connections they are close to breaking down the dynamics from the subsets into two parts. So phi of m xn is the minimum value of phi of m xn v for v a subset X. And then, so this gives you the best mechanism for which you cannot break the dynamic you cannot, let's say that you look at the mechanism, the best mechanism such that you cannot break the dynamic of its subsets on their optimal consequences. And then big phi, so this is the end of the presentation. So big phi so I leave the notations here. In the final definition, big phi of a state X is the maximum of phi of m of xn. So it's over n. So this is the end of the presentation with respect to the formulas. So if you have any question, like tell me, don't hesitate to tell me. Yeah.
So would you say that this characterization of IIT covers even the different version, including the latest ones,
So
in its whole generality?
so this is what I understand, and I think it's once again trying to say avec the concept. So once again, I think it's correct. So it englobes the work of Kleiner and Thune. I mean, it's a particular case of the work of Kleiner and Thune. Their work encompasses IIT 3.0, and what I present is more general than the classical version of IIT that they englobe. So it's less general than what they do because they also consider quantum case. I consider try to focus on a presentation that contains IIT, and then normally from this presentation by specifying the D, so the divergence you consider. So if you consider, for example, the passage time distance, it's the one that they consider in Training 2. You can also consider the pullback divergence, or in IIT 4.0, you can consider optimizing the likelihood, or at least you replace. So this I can say more about this, but just to answer the question is, I believe that. So there's, if you change D, you find a different version of IIT, but maybe they can be inconsistent. I don't have a clear vision on if they are inconsistent between each other or not. At least this encompasses the work of the tool that that encompasses IIT 3.0. And from what I read from IIT 4, there are some more specifications of the shape of T and some T that you choose, but normally you find something that has a very big overlap with IIT. But I don't have a precise understanding enough of IIT 4.0 to say exactly this is the specification that you on each different points. I can say, I think if you specify this to a certain quantity, then you get most of the results of 4.0, but this could be interesting to write, I think in the notes, more than a presentation, because once again, then it's an algorithm. IIT 4, IIT 3, most of them are algorithms. This is the core ideas of the quantities that are into play in IIT.
So when you say this is an algorithm, in opposition to what, with respect to, you know, an algorithm versus?
I mean, what I mean by algorithm is that there's a lot of specifications. Now, Gaspard will talk about more the relation to the axioms and the choice of these quantities. But as you see, there's a lot of, so with respect to what you're trying, at least the way I see it, but okay, I'm not an expert, but is that there's a lot of freedom in the interpretation of the actions with respect to the formula that could allow you to tweak them without changing the main ideas, which is basically that here you have two quantities on which you can play, D and T, but you can also add some coefficients. For example, why the weighting is phi of 8, for instance. Like, is it necessarily like this that it appear? Could it appear differently? Like, the reason for the weighting this can be justified, but the exact precise formulation, I feel that this is with respect to an algorithm, and that's why there's more specifications that makes it an algorithm. Here is basically the general conceptual framework, and I think that the versions then are in specifications of this. So what I'm saying by it's more algorithmic, I mean it's more like you define some functions that you call, and you define other functions with respect to this, but I mean like it's the precise shape of the precise definitions of the functions play a role more than their properties, which is that what is important is that with respect to the versions, they have explicit formulations for these functions, whereas you could think that you could have a general class of functions that would satisfy the same axioms. So I don't know if it's clear what I'm saying.
So if you now think a bit outside of the box of IIT and you look at this formalism at that level of generality, do you see any analogy or other theories or framework it would be subsumed into, or it would relate to? What does it come down to, according to you?
So I think we had this question, it's related to another question we had on the other seminar. I think like what is very interesting, so the bits, for example, the kernel is something that is very well used in most of engineering. The independency is very used in information theory. The fact that you give this explicit expression is also very well known when you study transition stochastic matrices. The general idea of trying to compute how far you are from independence, this is something that you can already find when you want to do do a test of independence between several variables, or when you find already the idea of how far you are from independence to be a quantity that is relevant with respect to statistical analysis. So now the thing that for me is probably more typical of IIT, which I don't necessarily understand fully in depth, is why you consider all these subsets of it. So this is something for me that is more, or at least I can't relate to something I already know. So this is why you consider, after you look at this quantity, which is natural if you want to know if your flow is like whole in a way, why you consider all the subsets also. So maybe in this case, Gaspard, say more from the axiom.
So there is a question by Robert Warden. He's asking, is there an opposition between IIT and the free energy principle? Do you see any bridges or differences? Are there relationships, you know, that you could identify between the two?
I'll try and explain what I mean,
IIT
if you like.
and the FEP, free energy principle.
I don't know.
Can you do active inference with that?
No, I think you can. That's right. So I just need to think a bit about the question.
Can you hear me?
Yeah.
The opposition might be that in the IIT, you get consciousness when you can't break the information out into smaller domains, whereas in FEP, there are lots of Markov blankets in the brain where information is isolated inside Markov blankets. So they seem to pull in opposite directions.
Can you repeat the question?
So the question was for IIT, you tend to look at how far you are from independence, whereas you're more interested in hierarchical models, so non-independent variables. It's not the quantity that you look at when you're considering active inference. Is it like this is the two are not considering the same, let's say, the same information on the model, the generative model you want to look at? Is it like, so basically, like they're not focusing on the same aspect. One is focusing on hierarchical decomposition of features, for example, and the other one is trying to understand how far you are from independence. Now, I still want to answer the first question. So I think the first question is you can add it to active inference in a way that, so when you're going to, so in active inference, you have in the simplest formalism, you have a PMMC. I'll take like the maybe not the probabilistic version of active inference. Like, let's say the PMMC with like the Bayesian version of PMMCs, but just like the classical one. Then it will take more time for me to really get into the Bayesian one. But so you have a PMMC. So forget this. And then at each time, so you have a prior on X, and you have a reward on every XI. So this continues. The reward on XI. So for all I have. So what? Yeah, the prior, you make an observation, and then you compute. So you have, let's say, the Z, Q, Z, Y, X, the model, and then at time t, you update X as Q of X to reflect your observation, but you can do it so you do it variation. But what I see as a relation is that if here in X, you consider dynamics that are also internal dynamics and not simply governed by actions. So this depends on the action that you will do or the policy. I can go into details, but this depends on the actions you will do. If you assume that you also have an internal dynamic, then you can define the T as being the pi. So let's say that X have some sets that are in configurations that are internal. So let's see, external, internal. So external with respect to describing the dynamic of what is outside the world. What is it? How is the outside world is developing? You can try to consider a T that goes only from the internal world to the internal world. Do active inference by updating your primes, choosing the optimal actions, and then computing the phi with respect to this dynamic. So I don't see an incompatibility between active inference and IIT, where because active inference is trying to give you some, the way I understand it, generative models of behaviors for adaptive systems. IIT is trying to quantify the states as being conscious states. So you could plug it, I see it as you can plug it into active inference.
Okay, thank you very much.
I don't know, but it's open to discussion. I mean,
Yeah,
I mean, it's a study group. I'm not an expert, so I think it would be good to have some, I mean, like discussion.
See anybody
No,
around?
no, I mean, so.
Chris, sorry, Robert, do you have a further question?
No, but just comments. I mean,
Or comments or anything you want to share or discuss, or Alain or anybody on the Zoom session?
I mean, saying maybe that doesn't agree or it's really nice.
No, that doesn't seem so.
No, nothing more from me.
Nothing more.
But do you agree with this answer or
Um,
saying that for you both are incompatible, both are on different paths?
I didn't catch all the answer because the sound isn't terrific, but perhaps we can talk about it.
So do you want me to repeat? It's okay.
No, Robert?
Yeah,
When, yeah.
I say I'm not hearing very well.
Je veux que tu coupes le son pour 2 secondes parce qu'on a l'écho. Robert, yeah, the deal is that when you were saying I did not catch everything you said, you meant when he was showing things on the blackboard, talking about, or just right now when you were having the discussion?
Well, generally not very well, but particularly in this discussion, I'm afraid.
So the thing is that I think that for active inference, what you have is you have an a priori Q of X on the states of the world, and you can also have in X states that correspond to your own states. So in X, you have your own states and states of the world. And then you're going to try to plan your actions with respect to some preferences, or let's say an a priori, but in this classical case, it's with respect to rewards. If you do the opposition with respect to PMMCs for the non-Bayesian, let's say, optimal control, and active inference as the Bayesian optimal control. And then what happens is that you're going to make an observation of the two a priori, and I was saying that the a priori you cannot compute it, so you do it variationally, and this is what one of the first part of the active inference algorithm. But what I was saying is that you can decouple, maybe think about decoupling the like there's maybe a way to decouple or to like the action, predicted action on the external variable and on the internal variable, and then your evolution that goes from internal variables at time t to time t plus 1. This is your transition t on which we'll apply IIT. And so in this case, IIT can, so active inference is a way to have a generative model of behaviors for adaptive systems. Active inference is a way to have a generative model for adaptive systems. IIT is a way to quantify, the way I see it, the wholeness of some states of your internal state. So I think you can apply to any dynamic, and in particular, the dynamic induced by the choice of the actions of an agent when it's following active inference. This is the way I see it. At least this is what comes to me when you respect your question.
Okay, thank you.
So maybe one last general question from me before we move on with Gaspard. Do you see that formalism and framework being applicable to a very broad set of systems that are not necessarily specifically conscious? What do you see in there based on whatever understanding you have of the field of consciousness studies that really, and I'm sure there is, I mean, I know in intention and initially there is good intuition there, but now that, things are worked out, and there are a lot of criticisms about the lack of specificity of IIT with respect to consciousness, where do you see in that something that more specifically could make sense about consciousness and perhaps as opposed to other theories? For instance, something, of course, we wouldn't find in the free energy principle in its most general formulation, but what do you see in there that you could tell, oh yeah, that's that actually seems to make very much sense about consciousness, number one, versus, but that I think, may or may not be that insightful or valid perhaps about as a basis to develop a theory of consciousness. And in a longer term, do you think that from this formalism, for instance, we could derive theorems that could be illuminating and bring us new things that we would not know necessarily about consciousness? Maybe you can reformulate. I know it's a lot.
No, it's so so I think so I had an answer and you think about it. So it's just so the first thing is I think that it okay, so I think the way I see it, so once again, so with respect to consciousness, I don't know if it says the system is conscious or not. It says I want to quantify some variables which are, I want to quantify from a dynamical system some variables which are very correlated with each, let's say that are intrinsic. Some things of the dynamic you cannot cut into pieces. And so this quantity is something that you can apply to any dynamical system. But this quantity, if you think about it, so there are two things. The first thing is finding from a dynamical system the quantity that you use, okay, that you quantify to be able to express something on it, is a way to use this quantity for the dynamical system to be able to have an opinion or an idea or to regulate its own behavior. So quantifying something on the dynamical system is always a good way for the system to have some feedback on itself. And this you can see it, at least from my naive understanding of higher order theories, as you have a building block that is higher on the Markov chain, which computes phi, and then maybe phi can be used functionally for other reasons. But you could compute also different things than phi. But at least phi has a specified idea of what it tries to capture. It's trying to capture how the things, elucidating the things that evolve in a non-breakable way. So I think this answers like just saying that phi is a quantity that you can use to see how much the system is whole. How much the variables how much the effects cannot be, because I focus on the effects, break into pieces. So it's a global effect over the dynamic on which that you can use as you quantify it as a feedback. So that's my answer. Now relating it to consciousness, I mean, in some sense, I understand why you don't want to break. You want to identify the states that are global, collective in a way. Now the link with consciousness, or for me what's more interesting, like the functional aspects of consciousness, that I don't know, because maybe there are studies telling you, but that I don't know about, how phi is correlated or associated to better predictions on the environment, or for example, how how it's correlated to the observations, because they correspond to global features of the environment to which you don't have access to localization. I'm just saying like an example of something that could, like, let's say, oh yes, indeed, this is the aspect of consciousness functionally that you're trying to look into. But I would say, of course, it's related to consciousness. But I said the way I understand it is the way as computing a quantity that can allow you to have a feedback. Now, why this the quantity I find nice in itself, but why this quantity that I don't know how to answer. I don't have enough knowledge, I think.
So I think it's very hard to do empirical science with, rigorously defined phi, because you need to have a lot of background knowledge about the systems, and it's not always, feasible. It's most of the time, it's generally speaking not feasible. But from a modeling standpoint, if you following basically up on Robert questioning, if you were now to insert IIT somewhat into POMDP version of optimal control, or a more full-fledged variational free energy principle-based active inference. Could you demonstrate? I mean, would it be possible? I mean, of course, that's. I mean, conceptually, are there any reason to think we could not combine the two to try to demonstrate whether or not adding this variable computed from IIT, as you think about it functionally, be used to improve predictive power or adaptive behavior?
I have an answer with respect to this, not with respect to IIT specifically, but with respect, how do you use this quantity, divergence from T, at least to a distribution from its bits parts, that's from the independent probability induced by subparts. It is when you're trying to learn some graphical model, or when you're trying to learn some interaction between your variable, and typically when you want to learn a graphical model. And this is something that can be used to, for example, for I'm saying like making the relation. Okay, you can imagine that you build a graph of your variables internally from computing this quantity. I'm not saying about this, but at least this quantity, and then this graph. As we know that there most of the time when you do observation correlated, you can use it then as something that is fixed, forged, and then you try to refine your generative model high with respect to the conditions, like with respect to the correlations that you have on your variables, and see if you get a better reaction adaptation to your environment. So what I'm saying is that it could be a way, at least this quantity, I think I saw it already. I mean, it's sure that this quantity are used to learn generative models. So it's not to make inference on the generative model, it's to learn the generative model. I think it's not, you're not just trying to compute the posterior, you really want to learn the structure of pi or T.
Interesting. Thank you. Okay, tu peux expliquer maintenant, Gaspard.
So Gaspard will now talk about the relation between the axioms and the formulas. And so we're very happy to have him. So Gaspard is working on consciousness studies. He's maybe you want to present yourself?
Hi, yes, my name is Gaspard Fougea.
Il a besoin du micro?
Ah, yes.
Yeah. We are low tech here, huh? Forgive us. It's just.
Oh,
Can you hear me correctly?
Anybody ask, for instance, Alain or Robert?
Alain, did you hear me correctly?
Oui? D'accord.
Attendez,
So, yeah.
je vous entends.
Hi, everyone. So yes, I was introducing myself. My name is Gaspard Fougea. I'm a PhD student at ENS Paris-Saclay. And the title of my PhD topic is Formal Models for Consciousness. It's under the supervision of Alain Funkel, who's watching us on Zoom. Yeah, basically in my PhD, I try to translate psychological phenomena and consciousness theories into formal models using computer science tools. So last time I came to the first seminary from Grégoire. Thank you very much, Grégoire. It's really interesting, and thank you, David. I came to the seminary, and at the end, I asked a question about the variables and their meaning. And David suddenly asked me, "Well, next time, would you like to just, talk a little bit about the meaning of the variables and maybe say how you feel about the theory just in an informal, way?" And I said, "Yeah, wonderful." And so I took some time to study a little bit the theory. So I will make a disclaimer right away. I'm not a specialist of the theory, and I don't believe to have understood everything about it. What interested me is, what is the methodology of IIT? What are the actions? Where did they start from? It's a very unique kind of way that they've created this theory. And what's the link with the formula? So that's what I'll try to convey. How much time do I have?
Anytime.
Okay.
An hour, a good hour if you
So
want.
it'll be about 2 hours. Can you guys see the screen okay? Yes?
Yes.
Okay, great. So yes, integrated information, integrated theory, discussion on the theory and the meaning of the formulas. So just an outline. So for some of you, this may seem very basic, but I'm just going to refresh our minds with what is phenomenal consciousness. Very oftentimes when I see researchers or I see talks about consciousness, it's not exactly defined. And I realize that many people attribute very different meanings to this word. For instance, Grégoire was just talking about functionality of consciousness to do with behavior, for instance. And that is it's actually entirely different than phenomenal consciousness. These are two completely separate objects. So I'm really going to define this so we're sure about what we're talking about. I'm going to explain the main pieces of the methodology and axioms of IIT. I'm going to do a bit of a larger discussion on the fourth action called the exclusion action. And we'll talk a little bit about the meaning of phi because it's very interesting. And if the theory is true, it's extremely powerful, right? What they try to explain is huge and immense. And yeah, let's go down to it. So references, I use mostly IIT 4 for the mathematical formulas. So in some ways, my mathematical formulas will diverge a little bit from Grégoire, but mostly it's the same, and we believe they have similar meaning at least. The other ones are more articles I've read to get different perspectives about the theory, and this is IIT 3 here, which I've used it as well to understand bits of the theory. Good, so the $100 question, what is phenomenal consciousness? Not an easy thing to explain or understand. There is there's a quality of it that cannot really be explained by words. So to get an idea of it, think of a camera, right? You take pictures of it. When you take a picture with your camera, it's going to pick up the color red, right? It's going to pick up the color blue. But will it experience red? Will it experience the color blue like this man who's clearly having a great time watching, looking at a painting, right? This man is feeling, experiencing, having an experience of the colors of red and blue. And a very legitimate question is, well, is the camera having any experience at all, right? So, yeah, so is the camera having any experience at all? Most people would say intuitively, well, no, of course not. Why? It's not a living being, right? Well, a theory like IIT tries to show that actually some non-organic objects may actually be having an experience. So it's a really fascinating question. So what is phenomenal consciousness? It's that feeling, it's that experience of red, of blue, of thoughts, images, emotions, feelings, whatever. Phenomenal consciousness is defined as this experience. IIT is a theory of phenomenal consciousness. So when we talk about consciousness, of course, in the sense of phenomenal experience, not in the other senses, three questions arise, which are all extremely important and profound. The first one is, how does phenomenal consciousness arise? Where does it come from? This question is called the hard problem of consciousness. Some philosophers actually may believe this question is beyond the scope of science, that we might not even ever understand it. Well, IIT believes it resolves it, but anyways, it's a very important question raised by many, and it's mostly David Chalmers' formulation, which was then re-exploited by many. The second question is, what is the structure? What is the content of my experience? You know, what is the content? How can we define and explain everything that I experience? That's the second question. And the third is, why even is there consciousness? Why do we even have an experience? So that's more the functional question. So Amazing. If IIT is true, then it's incredible. We'll discuss why we don't really know at this point, but IIT is a theory which claims it solves both the first question and the second question. And I'll explain in details how. Is everybody following so far? Great. Good, so let's go down to it. Methodology and axioms of IIT. So this is particular because most theories about consciousness will take as the starting point neural correlates or just something happening in the brain, right? Which kind of makes sense. Well, IIT has kind of a different bet and a different take on this. What they do is they start, the beginning point is phenomenal experience. Phenomenal experience being something that you can't really watch from the outside. I can't really watch your phenomenal experience from the outside. I can't really see what you're seeing, right? But they start with this, and they believe that there are 6 properties of phenomenal experience, which are 1, immediate, and 2, irrefutable. So this is where there is a very large discussion because, well, we'll see, but some of them, intuitively, many people will say, I do not believe that irrefutable. I actually maybe would believe the opposite. But anyways, that is the starting point. They have these 6 axioms, the existence, intrinsicality, and so on, and we'll talk about them one by one. So here, there's my phenomenal experience, and I have these properties. Now I think I have a physical substrate here. How do I make the link between the two? I will translate these actions into properties of physical substrates. That's the key point here, is this translation. I start with an action and then I translate it into a physical property. And then, well, these physical properties, I try to translate them into mathematical formula, and we get the formalism that Grégoire explained very well. Thank you, Grégoire. Is that clear? Because that's the... Okay, so... Good, so the actions themselves. So the first action is, irrefutably, I have an experience. And I like the argument they say, if I'm doubting about the fact that I'm having an experience, that's the experience of doubting. So doubting itself is part of the experience. Nothing can happen outside of this experience. So it's like, it's irrefutable, there is an experience. And then, as we said, first there is a philosophical action, and then we translate it into a physical property. The physical property here is, well, existence physically means there is cause and effect power. So, how do they translate that mathematically? If you consider substrates with a state space, so it's not exactly the same formalism. Here, the state space is all the different possible states of one, let's say, physical substrate. You look at the transitional probability, Px, which is the probability basically of moving from one state to the other. It's a Markov chain. This is what we consider Markov kernels. And basically, this is supposed to model cause and effect power. The cause is simply the state we're in the beginning, and the effect is the probability to move to another state. So this zero action is there to give the basic framework of the theory. Why are we even considering Markov kernels? Good. So the first action of IIT is intrinsicality. The intuition behind it is you don't see my own consciousness from outside. It has to be internal. Nobody can pick on the phenomenal experience from outside the system. So the system must be intrinsic. It exists for itself. So how they model this is they say for a physical substrate, it means the cause and effect power must be within itself. So if I have my physical substrate M and I have a larger universe, it means that here, X without M has almost no cause and effect power with M. This is intrinsic. We're not going to see consciousness from here, we're going to see it from inside here. Good. 2, information. This is an action to try to specify what exactly it is that we have as an experience. So they say, and they have some kind of maximal principle, that the information we choose maximizes intrinsic information, which is what they define formally as this. The intrinsic information between state X and state X prime is this, which is supposed, yes, to model the cause and effect power over itself. This one sounded a little strange to me at first, and then I understood that basically from a state, you pick another state you will go into, which maximizes this. This other state you go into will help you understand the structure itself of the experience you're having. So this is the building block of the structure of experience, of the structure of how you feel, hear sounds, see visuals in your everyday life. So the third action, I mean, it's the fourth, but the first one is considered 0. It's the starting point. And then they say there's 5 actions. Integration. So basically, my consciousness is 1. It cannot be split in 2. That's basically the idea. It cannot be split in 3 or 7. It just cannot be split. It's 1. You cannot reduce it to the separate parts. I do remember when I was studying cognitive sciences not far from here, my teacher was telling me that when he read this, he did not believe this was at all irrefutable. If anything, he was saying, I believe in certain states such as, coma or when you wake up, there might be different experiences happening at the same time that are completely unrelated. So once again, these actions do not feel irrefutable to anyone, but this is how they build their theory, and I think the methodology at least is really beautiful. So, how do you express this, that you cannot reduce it to different parts? Grégoire explained it perfectly earlier. You look for a partition that will minimize integrated information. So integrated information is the divergence that Grégoire expressed earlier, that basically measures how much you cannot reduce. Well, it's actually, it exactly says that, how much you cannot reduce the whole to separate units. If you can reduce the whole to separate units, yeah, it will not work, and you won't get the value that you're looking for. So we choose a partition which will minimize this value, and we'll calculate the little phi with M and P. Which is the formula right here. Is that clear for everybody? Okay. Good. Exclusion action is a very important one. This is the one where many debates are going. Many people do believe it irrefutable, non-irrefutable, sorry, which is my perspective as well, my own personal perspective, but I do not believe to own the truth. It's just an intuition. So it's not my intuition, but what it says is that, well, we'll go into the details later of what it philosophically says. Let's more talk about the mathematics. Basically, you choose a substrate. You will choose a physical substrate that will maximize this irreducible cause and effect state. So it's the formula we saw earlier. We're actually going to take the max on the P of what we saw earlier. This is what Grégoire was calling psi, what was it? Psi xm. Psi xm is what I'm calling here P star. And basically, once you found that set of units which maximizes this quantity, you call that a complex. And this is an important definition because the complexes, they are the conscious entities of IIT. They are the one that maximize this quantity, and that's what's conscious, and that's for which you will calculate big five. You calculate big five for a complex. Okay. So the fifth action is about composition. So again, this is the second big question about consciousness, which is, one was, how does it arise? Two is, what is its structure? How is our phenomenal experience structured, right? So here, experience is structured, it's composed of two things: distinctions, which I define here mathematically, and two, the relations that bind them together. And the distinctions and the relations give you the phi structure that feels the way it feels, right? Basically, this mathematical formula, think about it, is supposed to explain exactly how every single thought, emotion, feeling, perception you have exists, and how it is defined. There's supposed to be a complete equivalence. So mathematically, the distinctions, this part was quite heavy mathematically, so I decided not to explain everything, just to give the general idea. Basically, you take a complex that it is in the state X, you take subsets from this state, and you calculate, so you make a tuple, which is the subset. Z star is the maximal cause and effect state that we calculated earlier when we did action number 1. And then we calculate the little phi connected to that. And that is what we call a distinction. R to D will be basically a set of relations between the distinction. It would take some time to explain it, so I just thought the idea is what's more important here. And so the phi structure of the complex P star is the union of both sets.
Can you elaborate just a bit more on that?
Yeah.
Without necessarily going into 2 hours talk, but I think it's very important.
You mean elaborate on what?
Further explain and in more detail, and how
this is IIT 4, and so so the D relates with the.
Go close because the.
No, but you want to answer?
Yeah.
I think the thing is that with the specification of IIT 4, I think with the specification of IIT 4, what happened is that the difference that there is between this formalism and the one before is through Z star of M, which we didn't have before, because what they consider is the distance that is given by the formula you presented before, which is, maybe you can go 2 slides before.
Maybe you can just be boss in front of the board, and
So I think so, because we have been discussing about this, and it's the formalism of IIT 4, and this definition of II is something that we didn't introduce before, and I think this is the heart of the difference between IIT as 3.0, or at least what I presented with respect to the articles of Trainer and Chu, and the one in IIT 4.0. And so instead of having a sum between the P here, which was basically the divergence we had, then you take away the sum and choose an optimal point, an optimum S, and the optimum S is this. And this makes the link between IIT 3.0, or at least what you presented, and 4. But I think that this could be discussed in the notes. I mean, I don't know if you want to add something on it.
well, I think it's potentially very useful for whoever will be watching this, because it seems to be a very important pivotal point to connect, the general framework with a specific structure of a phenomenological experience, right?
Absolutely.
So that's not trivial. And if there is some substance to it, I think it's worth you, except if you don't want to, of course, spend a little more time on that, if you can.
yeah, basically. So you have P star, a set of units, complex. And it's in a certain state. So we'd say like this. What you're trying to do is you're trying to take subsets here. So this is M. And you calculate, so we're here in the whole universe X. You calculate what they call the maximal cause and effect state of M, which is basically the state that will maximize II. So there's another state here that it goes to X, and here N, which is basically different, and this will maximize II, integrated intrinsical information, which is what we saw earlier, which is this here, right? I should have taken different colors. So this is M. And then we do the calculation of phi, but with these smaller units of M and Z star. So we recalculate phi, and so the notations are here. We have, I believe, M, and here we'll have what they call the purview, which corresponds to Z star, the maximal state. I don't think it matters so much. This is a little technical, but basically, this is one unit of experience, which we calculate by the value here of integrated information. And every single element of this is a unit of experience. And then the way, that's what we'll see in a second, but the way they'll calculate phi, big phi in IIT 4, is that they will sum on the structure all the phi's, like here. So basically, the way I understand it, this is my own personal take on this, is this will represent, oh, this little thought I'm having. Another one like this will represent, oh, the color blue I'm seeing in front of me. These are units of experiences, and all of them put together gives the one whole experience. This is why there are subsets of my complex P star over here.
Is it consistent with the axiom of exclusion? I mean, formally, if there is no conflict here?
It's just
I don't believe so.
Okay.
No, I don't believe so. Actually, it makes sense. You're just calculating the sum of small integrated informations to show the big whole.
Okay.
Yeah.
Thanks.
Sure. Good. So this is what I just explained here. So yes, in IIT 4, the formalism is a little bit different than in IIT 3 and what Grégoire presented. And this has to do, as Grégoire explained, that the divergence function is actually calculated differently. So the phi's themselves are calculated differently. We have the intuition that it actually goes back together and it's very similar, but you know, that would be another work to try to bring the two theories together. Is everybody good?
Yeah, I mean, there is a question, I mean, a comment by Robert Warden. Axioms 2 and 5, most of the, most of the information in consciousness, most of the bits, that's, I guess, Robert's commentary, is spatial and geometric. We can talk about it. Maybe Robert wants to say something about that, but I'm reading what he wrote. Consciousness is structured and composed like space. IIT says, wait, let me read it. Little about space, except in this paper by Hone and Tononi, which I know. Is that a weakness of IIT? Or, and he says, in a strength of our model, the projective consciousness model. So maybe you can let, just since it's a dynamic interactive, maybe we can let Robert speak.
Yeah, it's just that what we're conscious of most of the time is the space around us. I mean, I'm conscious of a screen in front of me with rectangles. I'm even conscious of a room in Saclay, and it's all space. And I understand consciously the relations between these bits of space. It's very much about space. That's most of the information I get in my phenomenal consciousness. And so most of it is entirely spatial and geometric. Whereas IIT, as I think, says rather little about geometry. Hone and Turney had an attempt at it, whereas PCM is much more about geometry, and that's what I like about it. And it seems to me IIT is not really focused on the main problem.
Any comment? That's a big question. I mean, it's not a trivial one.
I think what is interesting in IIT is trying to derive from relations basically between objects, even small objects, to derive from that a meaning to consciousness, which seems to try to bridge this explanatory gap that seems impossible, right? And maybe as IIT develops further, when they explain this, they'll realize that within that operation here, there is actually space, right? We're not there yet, but if the theory is true, I hope they get there, right? At this point in time, they do not talk about it, but what I would say is it's not their starting point. It doesn't mean that their theory, I still feel like the theory is interesting methodologically, even though they don't deal with this aspect that I agree with you is absolutely essential. Now,
okay,
we have two specialists of the geometry of consciousness here. So if any of you want to talk more about it, it's not my field.
Another time, I guess, because perhaps we'll have some session that will be more focused on that, and here we don't want to go into a direction that would be taking us away from the specifics of that. But definitely, it'd be worth. With the help of Grégoire and perhaps Daniel Benquin, if he wants to contribute, to think about, IIT, for instance, the free energy principle and our own framework, the PCM, and think about how we could find or develop the type of theory we develop ourselves within or through IIT or, free energy principle. We're already doing it to some extent, but within IIT it would be nice. But you say, for instance, maybe from this formula over there, we will, by developing the theory, we will find space. But my concern is that the theory is somewhat, in the technical sense of the term, degenerate. So you would have to build it in. It would not be something that you can derive as a theorem, I believe. Maybe I'm wrong. But I know they have been trying to do so in one of their papers, but I think it's a bit questionable. But that's my open questions to it. Anyway, you should keep going. Thanks.
Okay. Good. So three, let's talk about the fourth action, the exclusion action. And now I'm going to give the proper intuition behind it. So let's just be very aware for this part that we're talking about intuitions. The action is an intuition that Tononi and others have said are immediate and irrefutable. So since we're talking about intuitions, we can use our own intuitions here. It's not, we don't have to say everything that has totally proven formally. So to explain the exclusion action in IIT 3, Tononi talks about the photodiode experiment. This is what it is. If you put a photodiode in front of a screen, the photodiode can only say whether there is light on the screen or not. That's all it's capable of doing. And then you put a man in front of the screen. Then there is a substantial difference in what the photodiode and the man will be, this is the important part, will be ruling out as experiences. So let me explain. For the photodiode, when it sees white, all that it's ruling out, the only experience that is not white is black, right? It doesn't have the capacity to differentiate more. Whereas for the man, seeing a white screen is different from seeing hippos dancing on a screen, zebras running in the bush, bees, whatever, you name it. What Tononi then says is, since the man rules out more possibilities, the man is more conscious. The more you can rule out possibilities of experience, the more conscious you are. The photodiode, being able to rule out only one possibility, is not conscious. That's what is explained. And that is an intuition that philosophers, and I've seen actually even scientists, do not agree with. So as I was saying, this is my personal take, and I do not believe to own the truth. But I do not find this intuitive or irrefutable, and I'm going to give you an argument why.
Before you proceed, it seems to me that what you just explained relates to the information axioms too, and not necessarily the exclusion axiom. For what I recall, I should have revised my IIT 101, but that there is a quantity of information to the extent to which that, the universe of possibility is large. But I could see how you could relate that to the exclusion axioms too, but I had a slightly different take on but anyway, so let's.
So from what I've read, what is written specifically in the papers and what I understood, this is the exclusion axiom. It's excluding other possibilities. And that concept is what is translated mathematically.
Because one of the discussion that have arisen is that, okay, if phi is a measure of whatever level of consciousness a system may have, based on the whole discussion we had before, then you could always find in the brain, for instance, complexes that would have a certain definite quantity of 5. But in order to only have one consciousness, you need to take one, for instance, with the maximum 5. And the exclusion axiom comes to say, okay, there is no worry. That doesn't mean that there are multiple little consciousness and there is one big one that, are not compatible, because for some reason, they are excluded.
So I do believe this is the action of, sorry, was it?
Exclusion.
I think it's integration. The fact that it's not separated by other.
No, it's from a whole.
The
but the fact that all the different complex, the fact that all the different possible complex on which a phi can be defined are not all individual little consciousness, but only one exists within the system, and that one is the one with the biggest phi.
Yeah.
They all relate to each other, but that was also discussed in the context of the exclusion axiom. How do you eliminate that possibility that you would have a multiplicity of consciousness within one system? You need to exclude all possible others.
Yes, okay, I see how that is connected to the exclusion action. Well, basically, I mean, it's what the theory says, right? I don't know personally how this works. I'm not within atoms to see, but what they say is if there is another partition that will take the max of the minimum of integrated information, then that is the one that is conscious and not the smaller one. The smaller one will not have bare consciousness. It's not a complex. I agree with you that I don't see a full proper justification to this from what I've read. Yeah.
I mean, it's one of the ongoing discussion about it. Okay. Okay. Thank you. So sorry for interrupting. But, I mean, I guess that's the principle of this discussion.
I'm not saying I understand everything. It's also interesting.
Me neither.
Because for me, like, I'm trying to follow the discussion, but like with the photodiode and the observation of a white, or let's say you observe a white board. Normally, even if you have more states that are than binary states, black and white, how can it be integrated into the T, so the dynamics, so that you can quantify the differences of, let's say, experiences? Like, what I mean is that I can see how, because your sensor is part of your state, and so you fix one state of your sensor, but this, like, would it mean that when you observe white, you would be less conscious because the purview P will have a phi that is lower because it doesn't evoke anything in terms of consequence with respect to what you observe? I mean, you see the place of, the first time I read IIT, I was a bit puzzled about the fact that everything was fixed a priori. It is all internal, and it's the state of the agent that determines completely his what he feels. And it didn't take into account observations or history or things like this. I mean, so everything was
I mean, history could be modeled in the state of the agents.
and how? Yeah, okay.
I mean, it could be different states or different vectors, right?
Yeah, no, you're right. You could, yeah, it could be meant.
Yeah. But for the information from the outside, I agree with you. Yeah.
Because you would expect like how the thing is that I don't understand the analogy between the diode and the man, because
the specific diode example that they take is a slightly modified diode, but we would,
no, but I think it's important to what is this experience trying to show? If you have a bigger state, if you have a bigger space, then it means that you're more conscious, or a more complex dynamic means that you're more conscious. Because if you see white, you would expect that something that can only distinguish white from black, white is extremely informative. Whereas for somebody that has a much bigger set of states, seeing white is in fact something very common and not very interesting.
So my intuition on this.
Maybe you can reformulate a bit Grégoire's question, because I'm not sure that anybody could hear that.
So Grégoire is asking, wait, what are these? That's for your question.
The relation between consciousness and the amount of states you have in the agent.
Yeah. And
the fact that for a photodiode, the fact of singling out one state is extremely informative, whereas for a human, it is maybe very worthless in terms of information.
Yeah, so the question is, if we have more states within the system, why would it make a difference? And for the photodiode, why would ruling out only one be such an information rather than ruling out others? My intuition, and it just came to me right now, is that if we have a substrate and we have these different states, if here this can take, let's say, n different values, then the more possibilities of values for each individual unit will be, the more cause and effect power there will be, right? So the more, since consciousness, the very basic thing for them is cause and effect power, you will then find that difference in each of the formulas one by one. That would be my intuition about it. It's not about having more states, it's about having more possible values for each individual unit. Does that make sense?
Yeah. But the thing is, like, take a photodiode.
Yeah.
Go to the world.
No, okay. That I'm trying just to understand, because the thing is ruling out some okay, so just what I don't understand, I think it's interesting because I'm not very familiar with all this thing. But so I would expect that for a photodiode, ruling out black or white is extremely informative. So it would be for it in a very aroused, like what I mean by aroused, like it means like very informative for it, and certainly feeling very conscious, whereas a human white is basically very uninformative, depending on the context. And so if you should expect that the conscious state with respect to the internal dynamics, even though the internal dynamics is very complicated for the human, is still low. And I don't know, I mean, it's just, I have no idea how to.
Well, I guess they would say that you cannot take any of the axioms and associated postulates in isolation. That's the whole IIT folks' argument. You need to consider all of it together to understand why, you know, for instance, you need to have also the integration.
But in a diode, you can define all this.
Yeah.
In a photodiode, you can define both models.
Mm-hmm.
I don't know, I mean, it's an open question.
Well, from the calculations they have, it makes sense to me that if every unit can take many different values, then the cause effects power will be greater, and the little phi's will be greater as well for the transitions. It just makes sense to me. I don't know if there's much more I could add to this.
No, but that's okay. Again, this is a
Yeah.
very free thing. We think out loud here.
Exactly.
So I know it. So sorry if we interrupt your presentation, but that's the game here. We just, you know, it's messy. So now you can of course continue your argument.
So this intuition is not obvious in the consciousness community. I do not agree with this intuition, and I'm going to give you the intuition of the background I come from. I have been studying my consciousness, but from the first person perspective for about 10 years now. I've been practicing meditation. I've been teaching meditation. And, well, meditation is an interesting tool to have intuitions, because what do? We're permanently getting in touch with our phenomenal experience. So here is the intuition. When we meditate, basically what happens is the mind starts to withdraw, and we start to watch objects without the mind interfering. So before I meditate, I see a tree, I think of the tree, I think of all the knowledge I have about the trees, I think of the birds, of how they might reproduce, whatever, just whatever knowledge I have comes to my mind. As I meditate, suddenly I see the tree, and I don't really have a thought about it. And what happens, what meditators experience, again, it's an intuition, but what they experience is that you feel like you see the tree so much more, like you're much more conscious of the tree. The perception feels much stronger, much more alive. Again, like this, we can't take this as, you know, an absolute truth, but it's just an intuition. And from what IIT says and the exclusion action, it seems like the more thought we'd have about the tree, the more we'd exclude the tree from other things, and the more conscious we'd be about it, which seems to go in complete contradiction. Personally, my meditative experience makes me think that information and data about objects have an effect on phenomenal experience, which go on the other side, which will tend to reduce the intensity of it. Does it make sense?
Yes, but I'm going to try to maybe argue. It'd be nice perhaps to have some folks that are more kind of IIT aficionados here, but I'm going to try to not necessarily challenge what you say, but just to make sure that the way you interpret it resonate well with what I understand of the whole thing. So again, I'm not sure about the exclusion axiom versus the information axiom, but let's ignore that part. But with respect to the notion that the more you have to exclude, the stronger or higher or more deeper your consciousness is. Somehow what you said, we could construe it exactly like that. When you exclude everything else, maybe those interfering thoughts, and basically the only thing that you manage to keep into your, let's call it for short, field of consciousness, kind of become the tree. It seems that there is a correlation between the exclusion of many other contents, so to speak, and it's what you describe in your meditative experience as all of a sudden the saliency, so to speak, of the tree increase. So we could see that with the narrative being like that, we could challenge you and say, oh, on the contrary, it seems that what you describe is actually very compatible with the notion. But I'm just for the sake of discussion.
No. It's an interesting way of putting it. I see thoughts as knowledge. The more knowledge I have about whatever I'm experiencing, the more I know what it is and what it is not. So the more I can exclude things, right? This is how I see it. For instance, if let's say let's completely assume I was ripped out of all my knowledge, then maybe I don't even know that it's a tree. Maybe I don't even know that I could have all these different experiences, and yet I could see the tree from very close, right? That's the intuition. Again, it's not mathematical, it's not formal, it's not proven. It's an intuition that I think meditators kind of share.
No, but I totally understand that experience you are describing, and I see you rational, but I think that some people could try to argue for the opposite conclusion based on the same experience. You see,
But this is flawed. I mean, that's flawed. I mean, like the argument, at least the one that you are saying, is I think is the sequence, which is that because you don't focus on something, you exclude things. I think it's the opposite of the fact of exclusion, because exclusion is getting more and more precise. Let's, for example, take the analogy with the probability distribution. You exclude states, so you concentrate the distribution on certain states. And I think this is the opposite, which is that what he's describing as not trying to focus is that it's trying to distribute the probability over everything, so that everything is as probable than the rest, which is that you don't focus on the content of the space you are in, but maybe more on something else, which is the conscious aspect. What I mean is that you're not excluding variables. You're not when doing this trying to exclude variables, because when you exclude variable, you focus the distribution on something. I see it more as trying to put the distribution on everything, like not you trying to single out something. So
yeah, I see your argument, but I'm not sure that's exactly what IIT says.
No, but the thing is that exclusion in what sense? In the sense of IIT. Exclusion in terms of IIT means focusing variables, focusing on collection of variables. Collection of variables corresponds to features, internal. The question is, how is it related to observation? But if there's a relation, local relation between what is observed, so the outside variables and the inside variables, they share some kind of locality, which means that the variable that you observe only have an impact on some variables that are inside of your internal state. Exclusion is singling out variables, and it's the opposite of trying to not singling out what you're observing. I think really the argument at least should be detailed, because in the implementation with respect to how I see IIT, it's completely, it's not what it's said by the formalism. The way that exclusion is formalized is opposite to what Gaspard presented. I have never heard the
But
term before,
I
and
would
just
look,
reacting
I
that
would
way.
look back at the axiom of information, because I think there's a slight mixing here of the two things. But as has been formulated more recently, I mean, for a while now, the axiom of information involves basically that the support of your probability distribution, the larger it is. So when you do, you have one outcome, because you have an observation, if you wish, somewhat, that's the way it is construed, you have more information than for something where you have less possible states. So the more possible states you have, the more information you gain.
But it's not what he's this. It doesn't feel really.
This is
the opposite.
yeah.
Is what he's describing. Sorry.
Well, I'm wondering.
What you're saying doesn't match to me, my understanding of the information postulates, which basically says you need to find a purview, a state to go to, which will maximize basically cause and effect power. And you need to calculate your phi structure from that. I don't really see the connection with this at the moment, but
it was in I guess the earlier version of IIT, that's
Okay.
and not that early actually. That's the notion of something being informative is because you have many more options that do not correspond to the experience you have now.
Yeah, no, that makes sense. This was what we were discussing just before.
No.
But I feel that what Gaspard is trying to explain is in the complete opposite direction from.
Yeah. But I'm just saying. I mean, I understand perfectly well it's rational, and I'm not saying I disagree with it. I'm just saying that perhaps in a different, in turning around the same experience, we could say, well, by considering only the specific aspect of the experience, by ignoring your thought or other perceptions like birds chirping or singing or other things that would enter your rich field of consciousness, then basically that somewhat could be construed as excluding, so to speak. I would not use exclusion here, but there are, many states that are not now considered within my consciousness. I do not access to them, and in virtue of that, the single out experience is more informative.
So what I would answer to that is that focusing on something does not mean that what I'm excluding by not focusing on them is not the same than what I'm ruling out as possible experiences. And even on that scale, for instance, even let's say that if it was true, if I'm only ruling out a bird chirping and a thought in my head, that's only 2 or 3 experiences. Whereas a human being is constantly ruling out gazillions of experiences.
Yeah, I totally agree.
I'm not seeing, people just dancing and whatever. So even if what you were saying were true, I do not believe that mathematically it would hold.
Okay.
That's what I would say.
Okay. You mean in that framework or in general? Okay. Interesting. Yeah. So continue.
Okay. Ta-da! The final point and the reason, I would say the reason why this whole theory is interesting is because big phi is a measure of how conscious the system is. This is what IIT claims. It's not something that is scientifically proven, it's a claim. Our big phi measures the quantity of consciousness, which means that if my phi is strictly positive, then the substrate is conscious, even if it's a car, even if it's, a system of, they've studied this system of opening and closing gates that interact. These systems might be conscious, whereas other systems, such as straightforward neural networks, will not be conscious because phi is equals 0. So IIT actually gave some kind of explanation of which non-organic systems will be conscious and not, which I find fascinating. It measures the quality of consciousness. So it gives an explanation of the hard problem of consciousness, the number one problem of consciousness, which is huge. And the second thing is, so we've talked about this many times now, is the equivalence between the properties of my experience and the phi structure. And I think that's beautiful. Once again, it means that every single experience I have, thought, emotions, feelings, sensations from my senses, everything, and of course all of that is processed with the brain, but from the brain, but all of that is equivalent to parts of the phi structure. So here it's a tentative explanation of the structure of consciousness. As I don't remember who was the person who spoke.
Robert.
Robert said, it doesn't account for specifics of the phenomenal experience. Like it doesn't explain how space works. It doesn't explain how sound is perceived, or at least not directly, but maybe indirectly through their formulas it will, or maybe not. But we'll have to wait and see. But I think this is the end of my presentation. So
Yeah,
thank you very much for listening.
No, of course.
And
Thank you very much.
everything.
Thank you very much for presenting.
Yeah, for
That's
presenting.
really nice,
And
great idea.
maybe you can move the thing here. So it's about 6 p.m. here in France. We could continue for a while, but typically it turns out that this seminar is about 2 hours. There would be a lot to discuss here. There would be maybe a lot to also go back to some details to make sure that we are talking correctly about the different axioms, and also things that would be worth elaborating further. So I wonder if we may not, since IIT, you just come into that field, and as many people who come into that field, it was my case when I began, and Tononi was developing the first version of his theory. We kind of say, wow, that's really intriguing. So, and there's a lot of debate in the community about the value of that theory, the promises of that theory, and questions about how it relates to different questions and different theoretical frameworks. So I think we should, without committing right now, say that maybe, probably we'll have an IIT session 3, okay? Because I don't think we can leave it that way, because that opens a lot of questions, and I think it would be worth making a connection, perhaps.
Or some other people that are following the seminar,
Yeah,
and they decide to.
I don't know if there are many people following the seminar, but at least among ourselves. Okay, so thanks for whoever has been listening to that online, or whoever will be listening to that in offline, I mean, afterward, post hoc. Thanks for everybody, Grégoire, and of course for Gaspard. And that will be the end of it for today, and see you next time.